Oh, good afternoon. This is Mr. Precella and we're here with our Math 13, 14 classes. Today we're going to look at lines. I know we graphed lines in the last assignment. We had those nice graphing tools. Today we're going to take more of an algebraic approach to lines. Oh, let's see. Instead of a graphing, yeah, I need to talk some, so let's see. Let me find those. We're going to look at equations of lines. If you're remember the last time I said that if the equation represents a line, you just have x's and or y's. You don't have x squared, you don't have y squared. The equation can be written in the form ax plus by equals c, where a, b, and c are integers. If your equation has both an x and a y, then you expect the graph to be a slanted line. A slanted line, by that I mean it's either rising, by rising I mean going up from left to right, or falling. Slanted lines have two variables, x and y. There are a couple of special cases I wanted to mention also. Suppose I said a, b, and c have to be integers. Suppose a were a 0. Suppose a were 0. Would we even have an x, a variable, appearing in the equation? No, we would only have a y. So if your equation contains a y but no x, a y but no x, if there's a y and no x, you could solve for y. So for our purposes, if you have an equation that has just the variable y, get rid of that coefficient in front of it. I'll write it as y equals a number n. There's a y variable but no x variable. In that event, the graph will be a horizontal line passing through the y-axis at the number n. We'll discuss more of why that is when we graph a horizontal line, but we know what a horizontal line is. It runs left to right. So a horizontal line is a line running left to right. And there's another special case. Suppose the y value, the y coefficient were 0. 0 times y, you wouldn't have a 0. You would only have that x. You say, well, suppose it's a, b, and c were all 0. 0 equals 0, you don't have anything. But to have a line, you have to have at least one variable, either x or y. So suppose you don't have a y. In that event, you have just the variable x, and so you can solve for x. If there's a coefficient in front of x, divide by it. You want the equation in the form x equals a number. If your variable, if your equation can be written so it's just x equals a number, your graph is going to be a vertical line up and down. It'll be a vertical line passing through the x-axis at the number n. If your equation has an x and no y, you're looking at an a vertical line. If your equation has a y and no x, you're looking at a horizontal line. That letter right there tells you which axis the line is passing through. Passing through the x-axis at the number n. I mentioned this terminology the last time, and I said it would be important. I'm going to state it again. Intercepts. Intercepts tell us where a graph intersects the respective axes. An x-intercept it's the ordered pair where the graph intersects the x-axis. I'll say where graph intersects is easy. Where the graph intersects the x-axis.
It's ordered pair.
And I'm going to write an example of the ordered pair. Recall that XY grid we were using the last time. I'm going to make it real fast. Draw a real fast XY grid.
You better move it up.
I'm going to. There. Oh, there. There and there. I remember drawing lines the last time. Here's the x-intercept. This is the point where the graph passes through the x-axis. So, I don't know that number that's right there, but I know the y-coordinate. In order for that point to be on the x-axis, what must be true of the y-coordinate? Every point on the x-axis has what number as a y-coordinate? 0. The y-coordinate has to be 0. So for an x-intercept, the ordered pair will have a number, but the y-coordinate will be 0. Because you can't move up or down, or else you'd wind up moving off of the x-axis. Likewise, the y-intercept that's the point where the graph passes through the y-axis. Looking at that y-intercept right there. Looking at that ordered pair. We can't go left or right if we're going to stay on the y-axis. So what has to be true about the x-coordinate? To get to this point, we can't move left or right. So x has to be what? 0. Okay. So for the x-intercept, the y value is equal to 0. For the y-intercept, the x value is equal to 0. And we were finding the x and y-intercepts of lines at the beginning of class the last time using that graphing tool. And with that in mind, I think we're ready to look at number 1 in this assignment.
Yes, it's always side to side. Hopefully.
Okay. Oh, well, why did I make that example up? Look at this.
I don't think this is one that needs any.
I think we can answer this. You've already written down an example. If you wrote down what I was doing over here, switch over. If you wrote down what I was doing down here, then I think that you don't need to bother writing this one down. Go ahead. I think y'all can pop that thing out.
Okay.
We want to know the y-intercept. At what point does the graph pass through the y-axis? It looks like they're incrementing in units of 1. So I agree with that. That would be the ordered pair 0, 5. You go left, right, 0, up 5. Are y'all counting that? It looks to me like it's a 5. Y'all agree? Yes. So ordered pair 0, comma 5. Okay. I bet you they want the x-intercept next. Let's see. Okay, pop it out again. Okay.
What should I type out here?
I heard it.
1,
0. I agree.
And what about y'all? Do y'all agree?
1, comma 0.
Yeah, they can't all be that.
Yeah, they can't all be that easy. I bet you the next one's going to require some writing.
Oh, okay.
Find the intercepts. When they ask for the intercepts, they're saying the x-intercept and y-intercept, and then draw the graph. Let me write this problem down. This is number 2.
I'm going to make an XY table.
Yeah, I'm going to make an XY table. X minus 5y is equal to 5. So, switch over. And I'm making myself an XY table. One day when you weren't here, Tony, I talked about if I could take over the world, or if I ruled the world, I'd be very benevolent. But one of the things I would outlaw are those variables that have curly tails in algebra class.
But if you wrote the Y like this, there wouldn't be a curly
Goodness,
tail.
Tony, I hate to say this, but you really do sound a little jealous of my perfect penmanship. All those penmanship awards, I tell
I've
you.
never gotten over it.
You never have. But do y'all remember what we would do to find intercepts? I mean, he does sound a little jealous. And look at those Y's and those, my curly tails there. It's just a shame that, there and there. So, y'all remember doing this? We're making this little table to find the intercepts. What's this first row saying to do? Put 0 for x, okay. So we have plugging in 0, we get 0 minus 5y equals 5. Well, 0 minus 5y, that's just a negative 5y equals 5. What do I need to do to solve for y? Okay, to give us y equals negative 1. So, yeah, okay. There's my first order pair, 0, negative 1. What's this second row saying to do? Put in 0 for y, so we're going to put in 0 for y. So we have an x minus 5 times 0 is 0 is equal to 5, so we just have x equals 5. There's my second order pair. Now before we, why don't we go ahead and draw the graph?
Oh, I was going to say, I'll just look at the answer choices.
Well, first, okay, I want y'all to do something. We're going to label the x-intercept and the y-intercept. Which one is the x-intercept and which one is the y-intercept? 0, negative 1. Draw that in your head. Picture that on a graph. Is that on the x-axis or the y-axis? The y-axis. You go left, right, 0. You go down 1. So there's the y-intercept. Remember I said the y-intercept will occur when x is equal to 0. What about the 0.50 then? It has to be the x-intercept, I agree. And now let's go over to the graph. Oh, we don't have to state that. We don't have to type in the graph.
No.
I mean the intercepts. This is nice. Can y'all see that? We're looking for 0, negative 1, and 5, 0. Which one has those intercepts? A, B, C, or D? C, do you see where they've showing where they've stated?
And I was going to show the graph.
But we didn't draw the graph.
I know, but is this over 0 down 1 for the y-intercept?
Notice the scale. They're incrementing in units of 2. And then the other one should be right 5 up 0. Is that it?
2, 4, right there 5. Is the answer C here?
I could tell it just because they stated the intercepts.
I wanted to show the graph.
Okay. Any questions? Next. Oh, number 3. Oh, I like this one.
Equals 2.
We want to draw the graph. It just says graph x equals 2. So switch over to my paper. Remember what I said at the beginning of, a few minutes ago. if your equation can be written in the form x equals a number,
then the graph is going to be passing through the x-axis at this number. You don't even need to memorize vertical. If you just think your way through, what sort of line passes through the x-axis?
Here's an XY grid. You're going to draw a line passing through the x-axis, and only the x-axis. What's it going to be? It's a vertical line. I remember back in the day when I used to teach the developmental courses regularly, I remember students saying, don't write this down, but they would say, if you make the little tick marks the way I would do it, okay, you go, let's say x equals, what is the equation?
2.
X equals 2. Go to the x-axis at the number 2 and extend the mark that's there. Isn't that a little vertical mark you put there? Just extend the mark. That's too messy. We're going to draw it. We're going to draw it neater.
So go to this axis and extend the little mark at this number here. That's clear what I mean by extend the little mark.
So go to 2 on the x-axis, and now let's discuss why is that line, I don't like that pen.
Why is that green line x equals 2? Why would we call that x equals 2?
People start having a problem because they think to themselves, well, the y-axis runs up and down, so this should be y equals 2. No. Think about ordered pairs. That point that I just now labeled there, what are the coordinates? If I wanted the ordered pair representation of that little point, what would it be? 2, 1? Okay. What about this one right here? 2, 4? Well, I think it's 2, 3.
No.
2, 3.
Oh, what? Yeah,
1, 2, 3.
Oh, okay.
That's okay. What about this point right here? That point right there. What would the ordered pair representation be? It'd be x is 2. The y coordinate is negative 2.
In other words, every x value is what?
On this green line, every x value is 2.
That's what this is saying right here. Every x is 2. It's got to be that vertical line. And I think we talked way too long for an easy problem.
A, B, C, or D.
I'm thinking it's B. I'll blow it up. See, okay, here. Each mark is 1. Is this a vertical line passing through 2 on the x-axis? Yes. There. Once again, this is the axis it passes through at that number.
Next.
Oh,
number 4.
Here's a good one. Is this, well, even if you didn't see the choices, this is not going to be a slanted line.
It's only got one letter in it, so it's going to be one of our special cases. If it's got x and y like number 2, it's a slanted line. But if there's only one letter, it's a special case. And for special cases, you need the variable solved for, the equation solved for that variable. So what do you think I'm going to do? So I'm going to make it y equals negative 4.
There's no other correct first step. You've got to get that y by itself.
And now we're going to draw the graph.
It's passing through this number on that axis.
I better put the little arrowheads.
Locate this number on that axis.
Now remember what we said. If your equation contains a y and no x, the graph will be a horizontal line passing through the y-axis at the number n. So with that in mind, looking at this equation, what number am I going to label on the y-axis very clearly? -4. I'm going to label -4. 1, 2, 3, 4. I need to move this thing up down there. There's -4. And then I'm going to draw a horizontal line.
And it wouldn't make sense to draw a vertical line if you know it's passing through the y-axis. If it's going to pass through the y-axis, it's got to be a horizontal line. A lot of times students get confused because, well, the x-axis is horizontal, but x equals is vertical. Yeah, that's right. That's why you've got to think. It's passing through this axis.
Give me some coordinates. Give me the coordinates of this first order pair that I just labeled here. What would the x coordinate be? 1, and the y coordinate is -4. What about this next one right there? What's the x coordinate? 2, but the y coordinate is still -4. What about this point? 3, -4. Every point on this line has a y coordinate equal to what? That's correct. The line we drew is the line that contains every point on the xy grid with a y value of -4. Any questions there?
It's not B. It's not D. Which one is it? C? Yep.
Had you had it on my, were you showing was he showing the paper as I was, Okay.
Oh, wow. These multiple choice make it move a little faster.
I was sitting up here thinking, I like this.
Okay, now you need
slope.
to talk
I need to talk to y'all about something. Okay. The slope of a line measures the amount of slant of a line. It measures the slant of a line. Is it real steep or is it real flat? It measures the slant of a line. It's a standard practice to let the letter M denote the slope of a line. You'll notice when I write the letter M like money, I know it sounds similar to my N like Nancy, but that's an M like money. And to distinguish them, notice for slope, I'm using 3 little humps. I'm using a cursive M just to show off my penmanship, I suppose. If we look at a line, if we graph a line and it's rising from left to right, when you look move from left to right, it's going up. Then we expect that slope to be a positive number. When we graph a line and it's falling from left to right, start on the left side and go to the right side, it's going down. In that event, the slope is equal to a negative number. Well, for the special cases, we're going to see that for a horizontal line, the slope will equal 0. There's one other type of line. What is it? A vertical line. A vertical line, when we talk about a vertical line, it's meaningless to talk about the slope. We say that the slope is undefined. We'll see more about this in a moment, but for the time being, a general definition of slope, just a general definition or a general explanation. The slope of a line tells you how the y value changes when you increase the x value by 1. The slope of a line tells you how the y value changes as x is increased by 1. Well, let's look at this horizontal line that I had here a moment ago. Notice I started off with x as 1. Then I increased x to 2. How did the y change? Did it go up, go down, stay the same? It stayed the same. Same things here. When you went from 2 to 3, x increased by 1. The y value didn't change at all. So the y value, that's why the slope of a horizontal line is 0. When you increase the x value, there's no change on the y. When a line is going up like this, as you increase x, the y value is also increasing. When a line is falling, you'll see that when you increase x, when you move over 1 for x, the y value goes down. The interesting one is this vertical line. If I were to ask myself, okay, here's a vertical line. Here's a vertical line. Let's increase x by 1. What happens to y? Is that even a meaningful question? With this vertical line, can we increase x to 3? Are there any points on this graph where x is 3? So for a vertical line, to ask yourself, what happens to y when you change x? That's meaningless. For a vertical line, you can't change the x value. So to ask yourself what happens to y, that doesn't even make sense. That's why we say the slope is undefined. Let's look at number 5. I think I'll go ahead. Let me do this first. We still have this just a general definition of slope. We still have this just a generic, just a general understanding of slope. We know that it's measuring the slant, and we know that it's telling us how y changes when you start changing x. But in terms of a graph, a very common general definition of slope is rise over run. You hear that, and I bet you a lot of y'all have heard that phrase before, rise over run. By that I mean you're looking at the change in the y values. How are the y values changing on a graph in relation to the change in the x values? So let's look at number 5. Where's number? Find the slope of the line shown on the graph to the right. I'm going to, I guess you're right. Their graph would look better than mine. But I need to write something, okay? So this is number 5. I'm going to draw this graph. Where are the intercepts?
It's passing through the x-intercept is at 1.
Okay. And the y-intercept is at
4. Back in the olden days, x-intercepts and y-intercepts were numbers, not ordered pairs. If it asked, what's the x-intercept, here you would say it's 1. But now we got to say 1, 0, right? It is an ordered pair. I remember when all the books started writing it as an ordered pair, I remember talking to my mentor, graduate advisor, dear friend, and she was like, I hate that. I don't know why they're doing that. They'll change it back. And no, they never
30 years later,
30-something years.
They still haven't changed it.
Yeah.
But let me draw the line. Okay. There.
Okay, well,
Let me switch
Okay.
over to my. Okay. All right. There. We know that the slope can be found using this concept of rise over run, but before we even do that, I know here's the slope. I know the sign of the slope. Do I expect this slope to be positive or negative? We expect it to be negative. As the x values increase, the y values are getting smaller. Because the way the line is falling, I know the slope's going to turn out to be negative. Let's show why. I like to start at the bottom point and work my way to the top point, using this concept of rise over run. I'm starting here. I have to get on the same level as the second point, I have to rise in the positive direction 1, 2, 3, 4 units. So I have a rise of positive 4. I counted up from the bottom point 4 units to get to the same level as that second point. Now the run. Am I going to be moving in the positive direction or the negative direction to get to this actual point? I'm positioned at this little X here. Will I be moving in the positive direction or the negative direction? It should be obvious. Right? If I move in the positive direction, that means I'm moving this way. Am I going to get to the point? No. So I'm going to have to move. I move left, that's towards the negative direction. And how many units will I have to move? So I have a run of negative 1. Positive 4 divided by negative 1, sure enough, that gives me a negative slope. The slope is negative 4. Any questions there?
let's see if is it clear here? You're going up 4, so that would be positive 4. Left 1, moving left is going in the negative direction. So positive 4 over negative 1 is still negative 4. Look at that option B. The slope is undefined.
If the answer had been option B, the slope is undefined, what sort of a line would we have needed? A vertical line. And the graph is not a vertical line. Vertical line, undefined slope. Go back to that number 5 and regenerate.
Oh wait, well, I haven't even checked. We might be wrong. There. Okay, you want me to So we're going to redo number 5. So I'm closing out this, and I'm going to say similar question. You can do that. You get similar questions even if you got them right. So now, oh wow.
But it doesn't look any different, does it? What I'm going to do, I always start at the bottom and work my way up. I'm going to make a classic new teacher mistake here, okay? That's a classic new teacher mistake. Oh, let's work this problem this way. Let's work it this way. Let's work it this way. The same problem over and over different ways. That invariably is not a good teaching strategy. The students get all the different methods confused. Logically, I would think, a new teacher would think, oh, that's good. They have choices on how they solve the problem. No. That's not a good idea. But we're going to do it anyway. I'm going to make that same mistake, okay? I'm starting at this point. Can y'all see where my mouse is? I'm going to start at the top point. I need to go to this. I'm going to move until I'm on the same level as this bottom point. Will my rise be positive or negative? What direction am I moving? Down, so I'm going in the negative direction. 1, 2, 3, 4, 5. So my rise is a negative 5. Y'all see where my mouse is? I'm positioned there at the origin. Y'all see it where I have the little pointer? So I have a rise of negative 5. What will my run be? I'm moving in the positive direction. So I'm moving 1 unit in the positive direction. Negative 5 over positive 1 gives me a negative 5. So it really doesn't matter you'll still get the same slope using rise over run. I just prefer, for some reason, I always start at the bottom one and work my way up. But you could start at the top one and go to the bottom one. Either way, you'll get the correct answer. Any questions there? Now, looking at number 7, they're giving you number 6. They're giving you ordered pairs, and you could just graph the thing, and then don't do this. But you could just draw the graph and then start counting rise over run. But eventually, that's going to get tedious.
Suppose instead of the point 5, 4, you had the point 57, 423.
I don't think you'd want to plot those points and then count rise over run. So here we have the slope formula.
We're going to use 2 ordered pairs and label them the same way that we did with distance and midpoint. Do you all remember those little subscript x1, y1, x2, y2?
There. Let's see. Given a line containing 2 ordered pairs, and I'll denote it x sub 1, comma, y sub 1, and x sub 2, comma, y sub 2.
Comma. You have the line.
Oops, x sub 2, comma. That's a comma there. Where's my liquid paper? I need to cover that up. I don't think they do either. Okay, that's an ordered pair, x2, y2. I don't like that. I'm going to have to mark it out and write it correctly. X sub 2, comma, y sub 2. The slope of the line M is M equals, I'm going to go ahead and write rise over run, and algebraically to get that rise, that's the change in the y values. Don't the y coordinates give you the vertical movement? So we'll say y2 minus y1, and the run, that's the horizontal movement. So the difference in the x values, x2 minus x1. Provided these x values aren't equal. So I'm going to say provided.
If the x values are equal, you'd have a vertical line,
Tony!
which would give you a 0 down there.
You just cut to the chase, I tell you, Tony.
Okay.
I'm just going to let them figure that out themselves.
Tony, to worry about that. Oh, well, 38 minutes.
Okay. So, did y'all get that written down? Tony's already switched over.
Important thing is this.
The y2 minus y1 over x2 minus x1. So, number 6. Okay. Let's see. Find the slope of the line that goes through the given points. The ordered pairs 5, 4, and 10, 8. Just like we did with the midpoint formula and the distance formula, I would identify x1, y1, that's the x in the first ordered pair, the y in the first ordered pair, and x2, y2. The x in the second ordered pair, the y in the second ordered pair.
Again, don't label it x1, x2. I've seen students do that and you get it wrong. It's xy. Ordered pairs are always xy.
Okay, so y2, that's an 8, minus y1 is a 4. I'll have been too quiet. Y'all tell me what number's going to go here underneath the 8. I couldn't hear you. I agree. The x2 is 10. The x1 is 5. And this works out really nicely. 8 minus 4 is 4 all over. 5. That's a positive number, so if we drew the graph, we're not going to, but if we drew the graph, we would expect it to be rising from left to right. All they want is the slope, 4/5. So if you increase x by 1, the y value increases by 4/5.
I think we have several of these.
There are several. Any questions there? Let me write down number 7. It's another, just find the slope of the line containing the pair of points 7, 0 and 10, 4. So, identify your x1, y1, x2, y2. Got it there. What's going to go here? 4 minus 0, and on the bottom, 10 minus, I couldn't hear you? 7. Wow, this is another one that reduces real easily just to 4 over 3. Once again, it's a positive slope. We would expect the line to be rising from left to right. Any questions there? Okay.
4/3. Next one's got to be hard.
Okay, number 8. Find the slope. It's the same instructions. The first order pair is -2, 5. Let me write it down. And the second order pair is 4, 0. Okay. I'd identify my x and y value, or my x and y values, I should say. That's my first x, first y, second x, second y. I just don't like that print y. It looks too much like an x, Tony.
Well, you don't like the Y with the tail. You don't like the print.
I like the way the Y with the tail looks, Tony. It's not that I don't like the way that looks. Okay, I just don't like the Y with the tail taking up all that space. Okay, so here we go. Here, 0 minus 5. I agree. Here, I could hear you. 4. No, not minus 5. 4 minus -2. Okay.
See, this is a little tricky because you have that minus and negative.
Well, first of all, let's simplify the numerator. 0 minus 5, I agree that's -5, but the minus and negative becomes, so 4 plus 2 gives me a denominator of. So we have a negative slope. That means if we drew the graph, would it be rising like that? No, it would be falling. You would expect it to fall from left to right. Any questions there? Okay. Yeah, let's find the slope of a line. Okay, right there. I'm making an example. I'm just making up an example, okay? Let's find the slope of a line. Find the slope of the line containing, and here are the ordered pairs. Let's say negative 3, negative 4, and how about negative 3, positive 5? So we identify our x's and y's. Here's my x1, y1, and this is x2, y2. Maybe it's time for me to restate that slope formula. y2 minus y1 all over x2 minus x1. And y'all caught up? Take a drink for y'all. What's going to go here? 5, okay. Minus negative 4, I agree. Here, negative 3 minus negative 3 minus negative 3. Well, look at the numerator. 5 minus a negative 4, what's that going to become? That's going to become a 9. 5 plus 4 is 9. What about the denominator? Negative 3 minus a negative 3. That gives me a 0. And what do we know about 0?
In the bottom.
Okay, what do we know about a denominator of 0? From the very, the second week of the semester, the third class meeting, I think we were talking about this. What happens when you have a denominator of 0? The fraction is undefined.
Punch that into your calculator. 9
divided by 0. What times 0 gives you 9? Nothing.
It's going to say error, divide by 0.
So we'd already got that intuitive notion, knowing, well, the slope tells you how y changes when you change x. Remember, we looked over here and I said, well, we can't change x. Here's a vertical line. You can't change the x value on a vertical line. So to ask what happens to y when you change the x value is meaningless. Well, if you tried to apply the slope formula to 2 points that are on a vertical line, then you get a denominator of 0. So either way, for a vertical line, you get a denominator of 0. The slope is undefined.
And that's why you have this option B. And you'll see it there. The slope is undefined. There. Okay? So if that happens, then you choose that. It didn't happen for these that we did right here.
Right. So that's
why. Ready to do another one? I'm ready.
No, I'm not ready to do another one.
Okay.
I'm ready to discuss something called the slope-intercept form of a line. I know. Okay.
Now we're looking at slanted lines. So those have x's and y's.
The slope-intercept form of y equals mx plus b. Oh. I don't know what's... Oh. I'll make y'all feel better. Hold on. Although y'all are far away from me there. Oh. Okay, there. Better take another drink also.
If we take a slanted line, we have the equation ax plus by equals c. We said if there's an x and a y in it, then it's a slanted line. If we took that equation
and solved for y, move the x term over, divide by b. So the equation is solved for y. That is called slope-intercept form of a line. Slope-intercept form of a line. And that's really the nicest form a line can be written, a slanted line's equation can be written in. If it's solved for y, the coefficient of x will automatically be the slope. So if you had a line, let's see. Like this number 2 here. If we had this equation and we wanted to know what's the slope, we could just solve for y. The number in front of x turns out to be the slope. This b value tells you the y-coordinate of the y-intercept. That's 0b is the y-intercept.
Earlier I mentioned my former graduate advisor, when they started calling y-intercepts ordered pairs. I remember her saying, we were lamenting it, oh, this is terrible, what's the world coming to? And she said, so what are we going to tell our students? Because up until that point, we always said,
M is the slope, B is the y-intercept.
She said, so we're going to have to tell them that B is the y-coordinate of the y-intercept. That's stupid. Well, 30-something years later, yeah, that's what we got to tell y'all.
Okay. So let's look at number 9. Find the slope and the y-intercept of the line. Let me write this down.
A lot of times you write down the problem and then there's a whole lot of scribble until you can get the answer. Like you're using the quadratic formula or solving an inequality using cut points. I wonder if any of y'all can tell. Is there going to be a lot of scribble to get the answer?
What is the slope? I don't know why I wrote the problem down. I don't need to.
This way you can circle something.
I think I heard you say it. Negative 8 over 9. The number in front of x. The number in front of x, the coefficient of x, is the slope. So go over there and type in the slope of negative 8 over 9. Now the y-intercept, notice they're really nice. The y-intercept, switch over to my paper. The definition that they started using in the late 80s is an ordered pair. So if a point is on the y-intercept, y-axis, we've said repeatedly the x-coordinate has to be 0. What's the y-coordinate of the y-intercept? 9. So we come over here, and what do we type there? We put a 9. They're not going to be giving you that ordered pair form for every one of the problems. Some of them you're going to have to type in. Here for the first one, notice they have the parentheses, they have the 0 already typed there for you. All you had to do was write in the b value. But I bet that doesn't continue for very long. Okay. Here's number 10. What's the slope? 1. If the equation is solved for y, it's easy to pick out that slope. It's the number in front of x. So 1/4, I agree. Oh, look at that.
Am I just going to type a 1 here? No, what do I have to type? I have to type an ordered pair, the 0, 1. Notice what he was saying earlier. Over here, you should want to leave, on this one, they had already typed the 0, comma, and the parentheses. So all you had to put in was the 9. Here, you have to type all of that yourself. Well, oh my gosh, I'm making it sound like it's so much. It's just my prejudice against this ordered pair definition of y-intercepts.
So we've been subjected to practically our entire professional career.
I know.
You know something? When I take over the world, it's not going to be the curly tail alphabet that I target. It's going to be that definition of intercepts. It'll go back to where an intercept is just the number on the x or y axis.
We'd say 1 is the y-intercept. We wouldn't have to say 1 is the y-coordinate of the y-intercept. There.
Tony, we've got to increase our effort towards world domination so we can correct that mistake. Okay, number 11. We're going to have to do a little writing here.
No, just 5x plus y is 5. It says find the slope and
It's
the
more
y-intercept.
writing than the parenthesis zero
Yeah.
comma that upset you so much, Tony. So, there.
I'm wondering, there's an extra step on this problem that we didn't have to do on the first two, or on the last two, I mean. On problem 9 and 10, it was already in the form y equals.
What are we going to have to do first here?
Yeah.
Okay, you got to get it in that y equals form. So we'll subtract the 5x to give us y equals, that's going to become negative 5x plus 5. So my slope is negative 5. My y-intercept, it's an ordered pair. Call it out as an ordered pair. 0, 5. Realize this 5 came from right there. The negative 5 came from there. Any questions on our logic?
Negative 5. Check the answer.
Are they going to give us the... No, you're going to have to type the whole ordered pair, Tom.
0, comma, 5. Close the parentheses. And check the answer. Have y'all caught up? Any questions?
What's better? What do y'all like better, this or the square root equations? Yeah, it's true. I mean, I'm telling you, that square root equations homework assignment, that was one of the worst of the semester.
And there were a few rational equations, but the fractions that got rid of that are really hairy. So. Okay.
Oh, number 12. Let me write it down. I don't seem to really have the hang of this. Y'all are on the ball, I guess. 9x plus... Not I guess, I know. 9x plus 3y is equal to 9. Can I just look and say the number in front of x is the slope? No, what am I going to have to do first? Okay, so we need to get the y by itself, so we're going to subtract 9x. That says 3y is equal to, here, and then to get y by itself, divide by 3. Notice, I'm basically multiplying 3 by 1/3. I'm dividing, you divide every term by that 3. The other option is to factor a 3 and cancel. That would be too much work in my opinion. So the easy thing to do is just whatever that y coefficient is, divide every term by that. That's then going to give us y equals negative 9 divided by 3 is a negative 3x plus 3. I can't believe it. They're still giving us these same numbers like that, just different signs. What's the slope? Negative 3. I agree. It's that number right there. What's the y-intercept? Oh, be careful. Call it out. 0 and 3. Okay. When I'm not recording, I'll tell you who I blame for. I can put a name to who I blame for that ordered pair representation of y-intercepts, okay? I remember the first author I ever saw do that, okay? And we met that author. He was trying to push a textbook at a school, and she's taking everyone in the department to lunch. Mazzio's Pizza, home of the $2.99 pizza buffet. True, it was in the 80s, and $2.99 was more then than it is now. But
It still wasn't a lot.
And we go all walking in there, the big group of math faculty, and this person says, well, I'm the famous textbook author, but everyone's staring at those twin boys. So,
no one knows math textbook authors.
Yeah.
Do y'all know? I mean, some of them are making
they're fabulously
millions
wealthy.
of sales.
They sell more than
So
Number 13.
now that's different.
Okay,
Up
but
until
writing.
this point, we've been given equations. Okay, told find the slope and stuff. Starting with number 13, you're going to see how to write an equation. Okay, so write an equation of a
If you
line.
view an example, you'll probably see something called the point slope form of a line, I remember the old 2-point form of a line also, but that's another hoax. I think we can do everything for slanted lines. All you need is the slope-intercept form of a line. Why have these other formulas for slanted lines? Y equals mx plus b will do everything.
They give you another form for a line and stuff. It's not going to make it easy or anything. We'll use slope-intercept form for all of this.
They want the final answer in slope-intercept form anyway. Look at that. So why use the something called the point-slope form if you're then going to have to change it to slope-intercept form anyway? So this is number 13. We're writing an equation for a slanted line, and I know it's a slanted line because the slope is 8. If the slope was 0, it's a horizontal line. If it's undefined, then it's a vertical line. But if the slope is anything else, it's got to be a slanted line. And the line is going to pass through, what's the order here?
9,4.
Okay. Let's switch to the paper.
So we're trying to write the equation in slope-intercept form. You see, it's already written y equals. We've got to fill in the rest of this, mx plus b.
So we know slope-intercept form is y equals mx plus b. And I think we know what m is. 8. They gave us that m is 8. So y equals 8x plus b. The only problem is they didn't give us the intercept. Is 9,4, is that the intercept? Is that on the y-axis? No, it's not on the y-axis. To be on the y-axis, that first number has to be a 0. So they didn't give us the y-intercept, so we don't know b.
We can find
find b because they gave us an xy. They gave us that ordered pair. They gave us an xy. So let x equal 9 and y equal 4. Let's plug in 9 for x and 4 for y. So plugging in those values, we have 4 equals 8 times 9 plus b. Are y'all following me? 8 times 9 is 72 plus b. We need to find the value of b. I think we've got it. What do? Subtract 72 from both sides to give us b equals 4 minus 72. Is that a negative 68? Don't box that in as your final answer.
The answer is an equation. Y equals mx plus b. The m is 8.
The b is a negative 62 or a minus...
64.
64.
68.
Negative 68. So your answer is y equals the equation of the line. Y equals 8x. And instead of a plus b, what have we got? Minus 68. Just put it into that.
Yeah.
For my final answer. We didn't need another formula to have to worry about. They gave us the slope. They didn't give us the y-intercept, but they gave us an xy. Plug in the x and y to find b. Any questions there? So y equals 8x minus 68.
68. So how is this different from what we had been doing? Here we're actually writing the equations.
Here's one.
Same one.
Number 14, but as a fraction, the slope is 8 over 9, and the point that the line's passing through is 8, -1.
Same instructions. Find the equation of a line.
And slope-intercept
Hey,
form.
it doesn't actually say give it in slope-intercept
But
form.
down there at the bottom, but it says y
equals the slope-intercept form. Oops.
Okay, so we know part of it. We already know y equals mx plus b. Which one of these letters do we know? So we have y equals 8/9 times x plus b.
What makes this one a little bit more involved than the previous one? The
fraction.
Okay.
But they didn't give us a y-intercept, 0, -1. It's an 8, -1. But we know that's an x and a y. So we're going to plug in -1 for y. -1 is equal to 8/9 times 8 plus b.
It's a good review of multiplying.
So we replace the y with -1, replace the x with 8. I'd multiply 8/9 times 8. Don't cancel out the 8s. You can't cross cancel because that 8 is like an 8 over 1. Okay? So you can't cancel those 8s. What's 8/9 times 8 over 1?
-1 equals 8 times 8, 16.
Okay, I heard it. Remember to multiply fractions. When there's nothing to cross cancel, you go top times top. 8 times 8 is 64. Then bottom times bottom. 9 times 1 is 9. 64/9. Rather than, I'm going to resist the urge to subtract 64/9 here, because then you got to get a common denominator, and people don't like adding and subtracting fractions. So what I'm going to do to avoid, now multiplying fractions, you don't need a common denominator. To multiply, you just multiply numerators, multiply denominators. But when we move that thing over, we'd have to get a common denominator, and I know how y'all don't like that. What I'm going to do is I'm going to multiply every term by something to cancel out that denominator. What can I multiply by to cancel out that denominator? 9. Now realize there are 3 terms. 1, 2, 3. So I'm going to say multiply by 9, multiply by 9, and multiply by 9. 9 times -1 is a -9 equals. What's this going to give me? Just 64. That's when we multiplied by 9 to cancel out that fraction. So we have 64 plus b times 9 is 9b.
Now do we know how to go about and solve for b? What are we going to do first?
Subtract the 64. That's right. -9 minus 64 gives me a -73 equals, what have I got over here? 9b. And then divide by 9, and we're getting our b value. b is equal to,
Can we reduce 73 over 9? I don't think there's anything I can divide above and below by.
I think 73 is a prime number.
Do we circle that?
Is that the answer we're going to type in? No. I'm going to circle it just to show you take it, you bring it up here, and it goes in place of that B right there. So we have y equals 8/9 x, and in place of the plus b we have minus 73/9. And this is the thing you type in.
Yeah, because it already says y equals 8/9, 8/9. I don't want to put the x down there. It'll count it wrong.
And it is wrong.
I'll hit the right arrow, x, and then what was it?
Minus 73/9. Any questions there?
We know how to write the equation of a line if we have the slope and a point. If the slope is just a whole number, it's a little bit easier than if it's a fraction. Well, what is it? We also, is it here number 8? Remembering something we did here, 7, 8, 9. If you have two ordered pairs, do we know how to find the slope? Yeah.
So look at number 15.
Let's look at number 15 and try to put some of this together. Last problem.
Find an equation of the line containing the given pair of points. And notice, even though they don't say write it in slope, yeah, they do down at the bottom.
Yeah.
They say write your answer in slope-intercept form. It needs to be a y equals. This is number 15.
The most basic problem-solving strategy is if you know how to do one problem, we know how to do problems 13 and 14. Here we're given a new one. Can we make this problem seem like 13 or 14?
What did they give us in 13 and 14 that they haven't given us here on number 15? The slope. But we know how to find the slope. Think back to the problems before we were writing equations. Don't you remember that slope formula? The slope formula, let me write it down.
So problem 7, 8, 9. That's why I was looking at those.
Okay. So before we can use y equals mx plus b, we have to find m. The other problems, 13 and 14, they gave us that m value. I think 12 did too. I think there were 3 of them. But here they didn't give you the m value. But you can find it using the slope formula. There's x1, y1, and here's my second x and my second y. So using that slope formula, what's going to go here? 5 minus, I couldn't hear you? 4, I agree. Here, 3 minus 1. Oh, this is a pretty nice slope. At least it's positive. It's not negative.
But it's going to be a fraction, isn't it?
But it's not too bad a fraction. It's going to be 1 over 2. So the slope is 1/2. So we know y equals mx plus b. That's what we're looking for. So I'm going to take that 1/2 and plug it in right there for y.
Now, on number 14, we were given the slope and one ordered pair. At this point, we have 2 ordered pairs. We only need one of them. Choose one of those ordered pairs. Okay? You're basically making
You'll get the
problem,
same answer. You'll get the same answer.
You're doing it as if the problem were this. Like number 14, if it, or number 14, if it said m is 1/2. Now you've got to choose one of these pairs.
Which
points.
one do you want to use? Makes no difference. 1, 4.
So pretend this is the problem. There's your m, there's your ordered pair. It's like number 14 and number 13.
So give me that green pen since you've been you started writing in green. There's my x, there's my y. So I'll plug in 4 for y. For x, I'm going to plug in a 1 plus b. 1/2 times 1 is 1/2. So we have 4 equals 1/2 plus b.
If you just want to subtract the 1/2 and do the
8 halves minus 1/2, you get 7 halves like that. But past experience has shown me that students get that b correct most frequently when they multiply to eliminate the fraction, so they don't have to add or subtract fractions. So what would we multiply through by to cancel out that denominator? 2. How many times do we have to multiply by 2? 3 times. Each one of those terms gets multiplied by 2.
8.
So we have 8 equals, what's going to happen here? Okay, the 2's cancel, leaving us a 1 plus b times 2 is 2b. And then move the 1 over to give us, okay, and that's going to give us 7 equals 2b. Divide by 2. So we know the b value is 7 over 2.
What are we going to type in as our answer?
You take that 7 over 2, you come back over here, replace the b, so we have y equals 1/2 x, and in place of plus b, we write plus 7 over 2. My lab's already given you the y equals. All you have to do is fill in the 1/2 x plus 7 over 2.
X plus 7 over 2. Any questions there? I was about to say something, my mind went blank about these problems. Okay. Hey, is this one where we went through every one of them?
I think we did.
Uh-huh.
That doesn't happen often.
Now, remember, if you find yourself, oh, I did all 15 problems and I have a 70-something average, or, well, you didn't click on all the media. On this particular assignment,
I quit requiring it
Yeah.
after a while.
oops. No,
I mean,
hang on, what do I need to do?
as I said,
Oh, I
it's
just say
easier
seven.
not to require you do the media first. So,
Oh, wait, no, there it is.
any questions there?
Uh,
Okay, stop recording.
okay.